Section 16 of Sun, Moon, and Stars, Astronomy for Beginners. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Sun, Moon, and Stars, Astronomy for Beginners by Agnes Giberne. Section 16, Mercury, Venus, and Mars. Thou hast made the heaven and the earth by thy great power and stretched out arm, and there is nothing too hard for thee. Jeremiah 32:17. Once again we have to journey through the high roads of the solar system, paying a brief visit to each in turn of our 7 chief brother and sister planets, and learning a few more leading facts about them. Having gone the same way before, it will not now seem quite so far. Busy, hurrying Mercury. We must meet him first. In his wild rush through space, if he were to slacken speed for a single instant, he would begin to fall with fearful rapidity toward the sun. And if Mercury were to drop into one of those huge black chasms of rent furnace flame on the sun's surface, there would be a speedy end to his life as a planet. Mercury's year is about 1/4 the length of our year, and his day is believed by Schiaparelli, from certain observations made, to be identical in length with the planet's year. This, however, is as yet by no means certain. If true, it would mean that Mercury revolves round the sun, presenting to him always one side only, and never the other, just as our moon revolves round the earth. Whether Mercury's axis slopes, like Earth axis, we do not yet know. More can be said about his orbit. The Earth's orbit, as before explained, is not a circle, but an ellipse or oval. Mercury's orbit is an ellipse also, and a much longer, or as it is called, a more eccentric ellipse. The Earth is 3 millions of miles nearer to the Sun at one time of the year than 6 months before or after. Mercury is no less than 15 millions of miles nearer at one time than another, which must make a marked difference in the amount of heat received. Even when the distance is greatest, the Sun, as seen from Mercury, looks more than 4 times as large as the Sun we see. What a blazing splendor of light! It is not easy to imagine human beings living there in such heat and glare, and with either no changes of season at all, or such very short seasons rapidly following one another. Mercury may, not impossibly, abound with living creatures of some sort, but they would have to be an altogether different kind of creatures from any seen on Earth. True, a very considerable power of adaptation is found here in many animals, especially in man, so that great varieties of climate, from extreme heat to extreme cold, can be endured. It is not easy to say how far such power of adaptation to circumstances may reach. Still, the extremest heat ever felt on Earth is as nothing beside that of Mercury, and the common sense view of things is very much opposed to the possibility of any life on Mercury identical in kind with any life known on Earth. The suggestion has been made that a moist, dense atmosphere might possibly help to ward off the overpowering heat and to make the planet more habitable. Experience, however, argues against this theory. Our earthly atmosphere acts in a precisely contrary fashion, serving as a storehouse for heat and rendering our planet much warmer than if no air existed. There is, after all, no need to conclude hastily that all these worlds in our neighborhood are, or must be, inhabited at this present time. Why, indeed, should they? With perfect ease, each world could have been adapted by divine power to its inhabitants, or the inhabitants to each world. But, quite conceivably, they may be destined for some entirely different purpose, lying outside the range of our knowledge and imagination. Or they may be still in process of preparation for future inhabitants, as, during countless ages, our Earth was in preparation for the little span of man's life upon her surface. We need not thrust our earthly notions of haste into the thought of the vast cycles of a universe formed in the infinite leisure of the divine counsels. If, in addition to a possible atmosphere, Mercury were surrounded habitually, as some have conjectured, by an envelope of heavy clouds, this might no doubt to some extent modify the desperate heat. The small size of Mercury makes attraction on his surface much less than on Earth. A lump of iron, weighing on Earth 1 pound, would weigh on Mercury only about 7 ounces, or less than half as much. So a man would be a very light leaper indeed there, and an elephant might be quite a frolicsome animal. If there should be stargazers in Mercury, the Earth and Venus must both be beautiful to look upon. Each of the two would shine far more brightly than Jupiter as seen at his best from Earth. Like Mercury, Venus, the next planet, has an orbit lying inside our orbit. Mercury and Venus are always nearer to the Sun than we are. And if Mercury and Venus traveled around the Sun in orbits the planes of which were exactly the same as the plane of the Earth's orbit, we should very often see them creeping over the surface of the Sun. Not that they really creep over it, only as they journey between the Sun and us, we can see them pass like little black dots across the Sun's disk. This is the same thing as when the Moon passes across the Sun's disk and eclipses it. But Mercury and Venus are too far away from us to cause any eclipse of the Sun's light. These crossings of the Sun's face, or transits as they are called, have been important matters. The transit of Venus, especially, was once eagerly looked for by astronomers, since by close observations of Venus's movements and positions, the distance of the Sun could at that time be better calculated than in any other way. Other methods are now coming into vogue. The transits of Venus are rare. 2 come near together, separated by only 8 years, and then, for more than 100 years, the little dark body of Venus is never seen from Earth to glide over the Sun's photosphere. There was a transit of Venus in the year 1761, and another in the year 1769. There was a transit of Venus in 1874, and there was also another in 1882. At the last transit, it was found that the Sun was only about 91 or 92 millions of miles away, while later calculations, of a different kind, have fixed the amount as close upon 93 millions. The reason why these transits happen so seldom is that the orbits of Mercury and Venus lie in rather a different plane or level from the Earth's orbit. So, like the Moon, though often passing between us and the Sun, they generally go just a little higher or just a little lower than his bright face. Mercury and Venus show phases like the Moon, although they do not circle round the Earth as the Moon does. These phases, or changes of shape, are probably never visible except through a telescope. It will be easier to think about the phases of Venus alone than to consider both together. Her orbit lies within the Earth's orbit, and the Earth and Venus travel round the Sun, as do all the planets, in the same direction. But as Venus's pathway is shorter than ours, and as her speed is greater, she is much the quicker about her yearly journey, and she overtakes us again and again at different points of our orbit in turn. At one time she comes between us and the Sun. That is her nearest position to us, and she is then only about 25 millions of miles distant. A beautiful sight she would be, but unfortunately her bright side is entirely turned away, and only her dark side is turned toward us. So then she is New Venus, and is invisible. At another time, she is completely beyond the Sun, and at her farthest position away from us. Her shining is quite lost in the Sun's rays coming between, and though we get a good view of her as full Venus, at a little to one side or the other, yet so great is her distance, as much as 157 millions of miles, that her size and brightness are very much lessened. Between these two nearest and farthest points, she occupies two middle distances, one on each side of the Sun. Then, like the Moon at her quarters, she turns to us only half of her bright side. But this is the best view of Venus that we have, as a brilliant, untwinkling star-like form, the evening star of ancients and of poets. Between these four leading positions, Venus is always traveling gradually from one to another, always either waxing or waning in size and in brightness. Mercury passes through the same seeming changes. If Venus owned inhabitants, they would have a glorious view of the Earth with her moon. At the time when the two planets are nearest together, and when she is only New Venus to us, a dark and invisible body, the Earth is full Earth to Venus. The very best sight we ever have of Venus cannot come near that sight. But if Venus should be so often covered with heavy clouds, as some have thought possible, this might greatly interfere with any habits of stargazing. Venus and the Earth have often been called twin sister planets. There are many points of likeness between them. In size, at least, they differ little. Venus, as well as Mercury, is believed by Schiaparelli to have a day equal in length to the planet's year, one face only of the planet being thus turned always downward. Mr. Trouvelot, on the contrary, as a result of other observations, reverts to the old idea that Venus has a day like in length to that of her twin sister, Earth, about 24 hours long. It is impossible as yet to know which will prove to be in the right. Mr. Trouvelot also believes that certain bright spots occasionally seen on Venus are very lofty mountains, showing their peaks above the thick atmosphere. This again is a reversion to, or at least an additional proof of, an idea many years old that mountains on Venus tower to 3 or 4 times the height of our stateliest earthly summits. There is a good deal of uncertainty about the climate of Venus. The heat there must greatly surpass heat ever felt on Earth, the Sun being about double the apparent size of our Sun and pouring out nearly double the amount of light and heat that we receive in our tropics in the hottest day ever known. Human beings, accustomed to earthly heat, could scarcely exist or keep their eyesight under such a blaze and glare as this must imply. It is believed also that the axis of Venus, instead of being slanted only as much as the Earth's axis, is tilted much more. Even if the tilting is less than some have supposed, it is probably very considerable. If Venus really does lie over in such a matter, certain startling changes of climate, unpleasant changes according to our ideas, would take place. Like Earth, Venus would have her 2 Arctic regions, where a burning summer's day would succeed a bitter winter's night, each half a year in length. She would have also her tropical region, only in that region, intense cold would alternate with intense heat, brief seasons of each in turn. And between the tropics and the Arctic regions would lie wide belts, by turns entirely tropical and entirely Arctic. The rapidity and severity of these changes, following one another in a year about as long as 8 of our months, would seem to be too much for any human frame to endure. But it all rests upon an if, and we may be quite sure that if there are any living creatures in Venus, their frames are well suited to the climate of their world. Though Mars is one of the inner group of 4 small planets, divided by the zone of asteroids from the outer group of 4 great planets, yet he belongs to the outside set of superior planets. His orbit surrounds ours, being at all points farther off from the Sun. Very slight phases have been seen in Mars. He turns to us from time to time just enough of his dark side to prove that he has a dark side, and that he does not shine like a star by his own light. But the phases are by no means marked, as with Venus. It was long believed that Mars possessed no moons. 2 very small ones have, however, been lately found circling round him. They have been named Deimos and Phobos, after the sons of Mars in Greek mythology. Deimos travels round Mars in 39 hours, while Phobos performs the same journey in the astonishingly short period of 7 hours and a half. Mars is not only much smaller than the Earth, but a good deal less dense in his make. His material is only about 3/4 as heavy as an equal amount of the Earth's material. A very heavy man on Earth would be a most light and active individual on Mars. Gold taken from Earth to Mars would weigh there no more than tin weighs upon Earth. There are good reasons for believing that Mars has an atmosphere. Indeed, it has been conjectured that Mars may possibly be somewhere about one of the smallest sized worlds able permanently to retain their atmospheres by force of gravitation. The surface of Mars has been more studied, because it can be more studied, than that of any other planet in our system. It is well placed for observation, being outside the Earth instead of between us and the Sun, and it is also comparatively near. True, at its very nearest, Mars does not draw closer than 35 millions of miles, and one has to be very cautious in making statements about a world 35 millions of miles away. But this is not much compared with the distance of Jupiter. And the surface of Mars presents features well worthy of study, albeit perplexing. Here and there, it is true, cloud forms seem to sweep over the landscape, blotting out what lies below. Still, though such appearances come and go, they do go as well as come. Mars is not, like Jupiter and Saturn, permanently wrapped in such masses of vapor that one cannot tell whether any solid body at all lies within. The reddish color of Mars is well known. This does not vanish in the telescope, but it is found that parts only have the reddish hue, while other parts are dark and greenish. These markings have been so closely examined that more is known about the geography of Mars than of any other world outside of our own. It is supposed that they may be continents and oceans, and names have been given to them, such as Dawes Continent, Herschel Continent, Airy Sea, Huygens Inlet, and so on. Land and water, if these markings really are such, seem to be very differently distributed on Mars from what they are on Earth. Here we have about 3 times as much water as land, and to get from one continent to another without crossing the sea is in some cases impossible. But a traveler there might go most conveniently to and fro, hither and thither, to all parts of his world, either on land or on water, without any change. If he preferred water, he would never need to set foot on land, and if he preferred land, he would never need to enter a boat. The two are so curiously mingled together, narrow necks of land running side by side with long, narrow sea inlets, that Atlantic and Pacific Oceans are unknown. These landscape features of the planets seem to be not absolutely changeless, like the continents and oceans of Earth, and, of course, any alterations seen by us from Earth in the course of a few years must imply vast changes of outline there. It may be that Mars is now in a state which Earth passed through many ages ago, a state of rapid geological change, rising and sinking of continents, and shifting of oceans. But it is at least quite as probable that the changes are in the main atmospheric, and that the continents and canals really alter very little. If clouds do actually float in the atmosphere of Mars, this means the existence of water in Mars. Doubtless, rain sometimes falls there. 2 singular white spots are to be seen at the North and South Poles, which are most probably polar ice and snow. Anybody looking at our Earth in like manner from a distance might perceive 2 such white snow caps. These caps are seen to vary with the seasons. When the North Pole of Mars is turned toward the Sun, the white spot there grows smaller. And, at the same time, the south pole of Mars being turned away from the sun, the white spot there grows larger. Again, when the south pole is toward the sun and the north pole away from the sun, the white spot at the south is seen to be the smallest, and the white spot at the north is seen to be the largest. This is exactly what takes place in the summers and winters of our north and south poles. It is rather curious that Mars' caps should be much smaller than ours, since Mars is farther from the sun. But Mars is thought to contain proportionately less water than our Earth does, and a drier atmosphere would at once account for a lessened amount of snow. End of section 16. Read by Phineas, Denver, Colorado, 2024.